Okay. Everyone's a structural engineer, I'm assuming, or soon to be.
Everyone is a structural engineer in this room.
You know, I always have a joke about the architects and the structural engineers.
That's why I-
Even we're having meetings, but I've never been surrounded by this many. And I don't know if I'm going to be able to get out the door here this evening. Anyway, I'm Peter DeMaria, and I'm co-founder of Midrise Modular with Diego Rivera. Diego is also has an architectural education. He'll talk about himself a little bit. But we are here because we are working with your professor on a really interesting project, which is a 10-story modular, volumetric modular, as well as panelized modular. 10-story building is going to be put on your shaking table. I don't think that's been done before. I think
It's stainless steel frame structure, and we'll be pushing the envelope. And we're trying to find all the ingredients from the architectural side. So this harmony between Diego and Peter has been amazing to bring the panelized and full-form steel industry together with the architectural side of things. And these students are learning about non-structural seismic design. They're all structural engineers. They know about the structure. Give them basic analytical tools.
Okay, well, thank you so much for having us. Thank you all for having us here. We're not structural engineers, but I think that we should be. And I think that even our own profession of architecture is shifting. It's changing. And I think that in our world of what we call productized architecture, we are always looking for systems and procedures that enable us to create a product, more so than a one-off customized project. And Diego is really incredible when it comes to that. He went to SCI-Arc, Southern California Institute of Architecture, and it's really a place for forward-thinking architects, and the premier school in the world. And for him to come out of there with the sensibility that he has, it's really unique. He's not like anyone else there. And they'll tell you, that's exactly the type of student we want to graduate from this program. So, but I'm going to let him confuse you in a little bit, okay? So I'm going to run out of the gate here. But why don't you tell them a little bit about yourself, and then we'll start up.
I guess I'm a little, I always, I give a lot of lectures on, in Latin countries, a lot of engineers. And I always question the engineering world, why every time they design a building in red iron, they have to add a millimeter to their thickness. Is it due to ignorance? Is it lack of material? Which is specs, correct? And it's all the three of them. So that had allowed me to, every time I do lectures to engineers and architects, it's just, how do you emphasize on the detail, the construction, the connections? More than the calculations, the math is never gonna lie. The numbers are always gonna be there. Numbers will define everything else. But how do you take it to the next level, like you saw today? How does that vent goes across that structure? And when you have a control joint, that control joint will not affect the air conditioning or the plumbing. And at the same time, you become a brilliant engineer. Like this building is really beautiful. First time we've been here, it was beautiful walking through this building to see we're like, engineers don't deserve this building so beautiful, But you actually guys have an interesting interaction between what architecture could be so simple to very, beams, and you have some, that staircase going in the back and everything else. Is that right? Oh, no wonder it's over-designed. We can tell right away that was English.
Yeah, it makes sense.
And I think a lot of the things that engineers need to start doing is spending more time in details. Actually get to see kind of what we're doing. Like in some of the panels we use, we run a 16th of an inch, an 1/8 of an inch tolerance. And when you bring those things into place with the magic of engineering and the connections and the details, I think we're gonna conquer what we need to do is go 10 stories. Be able to submit it to this incredible seismic, test, and we'll see what happens. I mean, we did the 6-story. When was that? 2016, and it was very successful. Yeah. We made a bet, $50,000. If she knocked it down, I get to recycle it. If not, I get $50,000 to knock it down. So I'm an architect who always lived, I guess, in the body of an engineer. So Peter designs. He's an incredible architect. You guys are gonna see with the module. So I tell Peter, dream and we'll build it. So basically I do whatever happens in between the walls, and Peter gives them the glamour of architecture in order to see spaces like this.
So along those same lines, I walked into this building. I said, this has got to be the nicest structural engineering building I've ever seen, because when I was in school, they were the ugliest buildings. They were all brick. They looked like old army barracks, and you're like, I went in and said, I never want to be the structural engineer. Look at what you have to live inside of. But you come here and you get inspired, because someone is really thinking a little bit about the folks who are going to use the building. And that falls in place a little bit with what we're going to talk about this evening. We all, like Diego says, the numbers never lie. And often our structural engineers, I had one structural engineer for almost 25 years until he retired. He knew what I was trying to do. And he always tried to help that happen. He knew my intent. When you start over with a new structural engineer, they don't know what your intent is. And rarely do they care. And it used to drive me nutty. So you have to find the right structural engineer who's into what you're doing, because they can enhance what you're doing dramatically. Okay? So this paradigm shift that I'm going to talk about really is about how a change is taking place in the profession. And I'm going to talk more and more about how the structural engineers and architects have so much in common, and how I think in the modular industry, you're going to have to think like an architect, and architects are going to have to think like you think. Okay? And that collaboration will take place, and you'll end up with some incredible results. So before we get too far into it, there are usually 3 reasons why people get into the modular world, right? Either they want to help mankind, get people off the street, provide housing for people who really need it, or they want to save the environment, and they say, listen, I want to do things in a recycled manner. And then there are the other folks who say, I don't care about people, I don't care about the environment, I need to make some money, right? Or I need to make some money so I can do these other things. So I can stay in business to help mankind, so I can stay in business to help the planet. Okay, so 1.6 billion people worldwide. I know we could talk about LA, but LA is just a small snapshot of what's happening around the globe. Most people do not live the way you live. Okay, so, and I won't get into this. This is a big political issue in California as well, but we are also, especially Diego, we don't just talk about all these things. We take action, and this is the reason why we're here. This is a project we did in Los Angeles. It's a homeless shelter with Mayor Garcetti's bridge housing program, and we were working before I got together with Diego. I was in China for 3 years, went back and forth, and we were creating modular buildings from cargo containers. But I was lucky I was able to go to the cargo container manufacturers, and they made my own box. Didn't have to cut it apart, so I made a building block there, not a cargo container. This translated into this project in downtown Los Angeles. It's 70 beds, it's rather large, it's got an iconic tower at the corner, and I could talk for hours about this. It's got all types of different awards. So that homeless shelter is really about helping mankind. So the next thing, when we get to the environment, okay, we can take all the cars off the road, and it's not going to put a dent in what you can, the impact you can have in creating buildings that are more energy efficient. The thing that I look at maybe more than anything else is the waste. There's no waste on our projects. When you work on metal studs, light gauge, cold form steel, you usually have somebody waiting out front to steal your garbage so they can get it and bring it to the recycling plant and get money for it. When it's wood construction, there's dumpsters, and they come in every week, and it's a mess. So these numbers are staggering that you saw there about the amount of waste that goes into landfills every year. Okay, so this is a traditionally built project. I'm going to show you some projects we have and historically, and then here you'll start to see a transition moving from wood frame into steel. This is a steel frame building. This one is the first cargo container building in the United States. We did this in Redondo Beach in 2005. It has all this acclaim. I have people to this day contacting me about container project because they've seen this thing over and over and over again. Go to the next one, but it's not just the containers. These are airplane hangar doors. So across the containers get all the kind of hoopla. Everybody's fascinated with them. But our whole kind of design aesthetic is predicated on either redeploying something that's being used in some other industry and then giving new life to it, okay? And everyone says, wow, that's really creative. But many of the problems that we're trying to solve, the solutions are already out there. They're just not in our industry yet. So that causes you or forces you to keep your eyes open because we're constantly borrowing from other industries to solve problems within our own industry. Okay, here's another one. This is built in the Las Vegas Convention Center. Okay, here it is with IKEA cabinets. Okay, and once we finished those projects, we found that the container reached a plateau as it stood as a shipping container. But then we said, wait a minute, what else can we do with this? So I was up in China, we started designing ADUs. From the ADUs, single family homes. And then here you'll see we built a prototype, put this in Vernon, had a bunch of people come over to see it, and they simply asked me, we were sitting down here, this became our conference room, they said, how high can you stack these? At that point, we were going in the ADU and single-family residence market. And I said, I think you can stack them 9 stories high. They came back in 30 days, and we had a $30 million contract to do a 70-unit apartment building in Los Angeles. Okay? Here's the project under construction. These are the modules that we created when I was in China. Had them all shipped here, got in just below the belt when COVID happened. Okay, the people who came after us, their stuff was sitting out in the port. This is the end product. It's 4 stories, I believe, over a concrete podium. Okay, and I learned a lot on this because really the connections, the structural connections, were a nightmare. They all worked. They were all structurally sound, but the work required to weld the containers together or to bolt the containers together, and then you had to cover that connection, then you had to waterproof that connection, was a monstrosity. So now you'll see we're working with something called a unitized facade that covers all of this stuff, and we're working with MyTech on a blind connection, and we have it all resolved, and there's no scaffolds and all these other wonderful things, but we learn on each one of these projects. Okay? So real quickly, people, planet, and then the last one we have here is profitability. So let's jump to the next slide, and you'll see we created Mid-Rise Modular. Diego and I got together at the World of Modular Conference, and we had some mutual friends. He's basically in my backyard. I've been in Manhattan Beach and Los Angeles for, since 1992. He's in Southgate, and we actually hit it off. We got stuck in traffic coming back from Vegas for 5 hours. So I got to talk to him for 5 hours. So I knew everything about this guy, his family tree, the whole deal. How many nephews? Like 38 nephews? So we really got into it. If you have to talk to someone for 5 hours and you think they're a good guy, you'll do it. We got back here and said, you know what? Let's give this a shot. Let's talk. And that was a year and 3 or 4 months ago, something like that. We formulated a company. I brought my knowledge of the 3D volumetric world together with the precision that he has in his shop. He's been doing 2D panels for the last 12 or 14 years. And when I walked in and saw just the process, the procedures, and the discipline of the people who were working in there, I said, he solved the problem that he wasn't trying to solve. He solved the 2D problem, but he's actually solved the 3D problem, the volumetric problem at the same time. So I saw incredible promise in all of that. So we got together, and one of the things that was really incredible, and leave this slide on for 1 second, all these people up here, okay, we have, I think, six 3D Revit modelers, and they build the entire structure with all the different engineers, and Diego's going to talk about that in a little bit. But the unique thing that I found when I went there is every one of those people started on the factory floor. They weren't what we call, like in the world of architecture, we call them paper architects. They do all this nice, beautiful drawing, but they never build anything. These people knew that, yes, the screw fits in the hole, but they know how big that drill has to be, okay, in order to get to the screw. So that means there's not going to be any headaches or changes. These are people with boots on the ground, with experience. And I said, this reduces your chances of error, change orders, all that to this minimal level. So to me, that was really important. In the traditional world of construction, it's like, what's the big deal? Sand it down, cut it off, change order. That's the way it works out there. But when you're doing something that's a product or productized architecture, imagine you have to, what happens when something goes wrong in your car, right? They send it back and they go, oh, there's a recall. There's a massive lawsuit and everybody under the sun is worried about driving their cars. She's been through it. It's crazy. But in the productized world, you can't do that. In the traditional world, what's the problem? Right? The RFI, the contractor's happy, they get paid more, right? Okay, let's go to the next slide.